I hope you all had a good lunch, and I hope you're ready for our new speaker, the next section of our symposium. So I'd like to welcome and introduce Lisa Osbeck, who's a professor of psychology from University of West Georgia, and she's here today to speak about epistemic virtues in interdisciplinary science. And this is a talk that's based on work that she has done together with Professor Nancy Nersessian, who's a professor of cognitive science and philosophy at Harvard and Georgia Tech, right?
Georgia Tech in the past and Harvard
and Harvard now, yes. And she's not here, but Lisa is going to present their joint work.
Thank you very much. And I'd like to begin by expressing my gratitude for the invitation and the hospitality. It's been wonderful. And also, I need to express thanks to Nancy Nersessian for many things, actually, but also for recommending me, suggesting me in her place when she was unable to make the conference. I'm going to be talking about some work that we've done within the context of her 15-year study, her ethnographic study of bioengineering laboratories. Just an overview of what I'll be presenting. I'll look at the affordances of interdisciplinary practice. This has already come up in several other talks, but just a bit of the review. The epistemic features of interdisciplinary science, or the specific epistemic situation of interdisciplinary science labs. A description of the study as 4 distinct configurations of interdisciplinary practice. Then I'll move into challenges to integration within these settings, specific challenges in relation to the specific interdisciplinary configurations, and general challenges across labs. I'll look at the meaning and relevance of epistemic virtues in the context of the epistemic situation of interdisciplinary science, and then I will talk briefly about how epistemic virtues might be cultivated, some developing ideas around that. So the formal definition we've all been using, but just the standard one, a mode of research by teams or individuals that integrate information, data, techniques, tools, perspectives, concepts, and/or theories from 2 or more disciplines, just to orient us here. The affordances, as have come out in other talks, generally are discussed or assumed to be in 2 categories. One having to do with the assumption that creative problem solving, especially in complex situations, requires resources from more than one discipline, of course, but the other has to do with flexibility and adaptability. The idea that multi-perspectival collaboration will generate more adaptable tools, and that these multiple views, as in this definition, will advance understanding. So the affordances of interdisciplinary science labs in particular, as case studies of interdisciplinarity, are important because they represent an interplay of various factors, various dimensions of practice: cognitive, social, cultural, and material. And in our case, as these integrate at the frontier of innovation in the sciences, they are also evolving communities. That methods are changing and undergoing really some very interesting transformations, or evolving discourses, artifacts, and understandings as these disciplines interact, as older persons leave, newer persons come in with their problems, and the whole system changes. They are, of course, significant sites of learning, and they are normatively structured contexts of practice. And what's most interesting about these interdisciplinary sites is that the norms are, of course, in negotiation as people come in with these different backgrounds and different expectations about what science entails. So what we have called the epistemic situation in science and engineering labs, the particular features include the fact that they are pioneering and extremely fast-paced, the fact that the novelty required includes novel ways of interacting, as well as novel ways of practicing, of collaborating around epistemic practices. The emerging practices outpace education. In many cases, there are no textbooks available, so the position of the researcher in many cases, the student who comes in, is simultaneously as a learner, a student, and as a pioneering researcher in the field. We have found that different kinds of interdisciplinary research present specific challenges, and we need to understand what these specific challenges are in context rather than just make generalizations about what's needed. On the other hand, it's also possible, I think, to step back and make some kinds of general comments, which is what I will be doing today. A key question then, what are the cognitive and learning practices in research labs across and within different emerging bioengineering sciences? What are the similarities and differences? That's important in any reasoning task, of course. Different configurations of interdisciplinary problems, different problems and goals, but then, of course, what can be said in general. So our ethnographic investigation, this is an old picture. You see Miles there, who follows me. Next to Wendy Neustetter and Nancy Nersessian, who are the principal investigators of this large and very complex project. They were tasked to understand innovation practices in frontier interdisciplinary science, and then to provide some recommendations for science education on the basis of what was found through the ethnographic study. It consisted of a study of 4 bioengineering labs, 2 in biomedical engineering and 2 in systems biology. Lab A is a tissue engineering lab. For example, looks at blood flow in arteries and how artificial blood vessels might be manufactured. Lab D is a neuroengineering lab that tries to understand learning at the mechanistic level. Systems biology entailed a study of a biosystems analysis lab where computational modelers have to collaborate strategically with experimenters on problems that are determined by bioscientists. And in Lab C is a modeling and wet lab, the task of which is to investigate inflammatory processes in cells. So 4 different sites, 4 different labs that are studied for their particular features. Now, the kinds of challenges or the kinds of things that have to be understood, particularly in terms of biomedical engineering, the form of interdisciplinarity required is understood best as a kind of interdiscipline or as a hybrid model. This is a quote from one of the researchers. Biomedical engineering is an interdiscipline, a field that is inherently interdisciplinary, meaning that as a discipline, it incorporates concepts and methods from materials as well, from medicine, from biology, and from engineering in a goal of building physical model systems in the service of complex problem solving. So all 3 are inherent to the practice. And so the task, what is required, is the cultivation of hybrid persons who are themselves inherently integrated in their practices. Integrative systems biology, on the other hand, requires a situation of epistemic interdependence. Deep disciplinary knowledge, but also knowledge of when and how to engage the other disciplines strategically. Here's a quote from one of our participants. For me to be able to sit here and think that I can have all the expertise in my tiny little brain, that's not how it's ever going to work. You're going to be much more on one side than the other, so you need half of your bioscientist brain to be in another person, a modeler. So the situation is one of epistemic interdependence, and what it requires is a cultivation not of hybrid persons, but of boundary agents. Okay? So just as a kind of review, these 2 forms of integration require cultivation of 2 different kinds of interdisciplinary researcher. I like to think of it, as I said, as 2 different kinds of person. So in both cases, however, challenges to integration arise around translation problems, as is described by many other people, but also around norms, as scientists with different backgrounds come in with really different ideas about what constitutes good science. And they must continuously collaborate with these differing expectations, these differing normative frameworks that have shaped their own conception of what it is science entails, what it means to do science well. So Nersessian and I have coined this term epistemic identity for the reason that identity is a kind of whole person concept. It entails not just a kind of epistemic stance, but also engages the person affectively. It's a matter of value. It's a matter of participation in a social group, cultivation in a particular group, by means of one's education. And these identifications are not neutral. That's very important. They reflect values, but they also reflect one's view not only of oneself, but of others. These are some examples from our study. I guess being a biologist, the whole thing is finding out how things work. It's an experimentalist mindset. It's still what I have. We aren't theoretical modelers. We don't just come up with ideas and then shoot them out and wait for people to do them. And then, when you're an engineer, you used to work with exact stuff and formulas, especially in my area, it's like a very neat little problem. So I don't think that these are neutral statements, right? These are statements that characterize their own practice, but also the practice of others. And we engaged positioning theory, something derived from the new social psychology, as it's called, with roots in many places, Goffman, even Adler to a certain extent, Wittgenstein. But the idea that discourse, talk positions people metaphorically in space, in a sense, higher or lower, and so on. And if we look at the way people are positioning one another, we find some very revealing things in these interdisciplinary settings. So, for example, we found that modelers position experimentalists in certain ways which could be understood as disparaging, as recipe followers, for example, as mathematically inept, as unable to handle complexity, the complexity of models. On the other hand, we also found that modelers were positioned by experimenters in ways that included things like being experimentally naive, not concerned with accuracy, engaged in modeling for the sake of modeling without relevance to real-world problems, for example. So you can see this kind of mutual positioning, with disparaging kinds of implications in many cases, might be expected to have some effect on the potential, might constrain the potential for collaborative work in some way. Now, we did not yet do the work of analyzing specifically if and how this does actually negatively impact collaborative practice in specific settings. That would be important work to do. But I think we can assume analogously from other situations in which there are conflicts between groups that these could be potentially roadblocks to collaboration if they are not understood and addressed. And these are implicit. These are not things people are saying to each other. We interpreted this in the interview content that we collected in the context of interviews about practices, for example, that had nothing to do with the interaction. Okay. So as a means of trying to think of ways to confront these limitations or these potential problems in relation to the possibility of integration, we began to think about the notion of interdisciplinary epistemic virtues. Virtues, of course, being understood as deep and enduring acquired excellences motivated by reliably successful at achieving intellectual ends, with the idea that they are sensitive to modifications in the situation. They're not automatic, but they are sensitive to its form of expertise in a sense. Interdisciplinary epistemic virtues are those needed for achieving the epistemic aims, specifically of interdisciplinary science. Aristotle, of course, described two kinds of virtue, intellectual and moral. The relation between those is subject to various interpretations. Truth, for example, is arguably both a moral and an intellectual virtue. But virtue ethics is, of course, an older field. Virtue epistemology is more recent, relatively more recent, since about the mid-'80s, but increasingly popular in various contexts, including in accounts of intelligent action in relation to theories of knowing how, for example. The reason that it's important, I think, in relation to situated learning contexts, the study of interdisciplinary learning, is the assumption that virtue is at least in part acquired through practice, development of competencies, for which reason a skill analogy is often used in relation to virtue. Aristotle believed that natural dispositions, natural abilities must combine in some way with the acquisition of competencies, but practice is a definite component of virtue. And in relation to intellectual virtues in particular, Aristotle acknowledges the importance of mentoring, what we might call the educative community. So it's not just an isolated individual kind of concept, it's something that implicates the community. Importantly, too, the focus is on practices of persons. I use the term whole persons because that has a particular meaning in my context, but it means really here that the various dimensions are implicated. Cognition, certainly, but also affect and social interaction. We, in other work, have argued that the acting person in normatively structured contexts of practice is an important unit of analysis for the science studies and one that has been neglected. It's important as a way to bring in the kind of interface of the personal and the social, right? And not just these kind of isolated things as they are often studied in various contexts. So interdisciplinary virtues that we have talked about, specific things relevant, I think, to interdisciplinary science include cognitive flexibility, methodological versatility, and resilience in the face of impasse. So far, these are things that could be characteristic of any form of science, virtues in any science, one might argue. But there are specific virtues, intellectual virtues, epistemic virtues that are specific to interdisciplinary science that have more to do with this kind of interactional expertise. And they would include then what we have called interactional expertise itself, which might be composed of various things I can talk about in a moment if I have time. But the other is epistemic awareness, this idea that one has to reflect on the normative assumptions about the nature of science and what it means to practice science well, that one brings into interdisciplinary collaboration, and also to be aware of how those might differ from the ideas that other persons are bringing as well. My own interest recently is in the idea, the exploration of how the activity of perspective taking might be cultivated, how it might enhance all of these epistemic virtues, and in turn might promote innovation and creativity. Perspective deserves a paper in itself, or 5 papers. It's one of these terms that's overused and somewhat meaningless, but on the other hand, I think it has been abused by this idea where there has been a kind of detrimental effect of the idea that we come with a perspective and we can't step outside of that. We have found through some of our data that researchers are actually able, through the right kind of experience, to do a kind of shift in perspective taking, which has certain implications which are positive both for collaboration but also have positive effects on the science potentially. So just as an example, in one case, an experimental kind of summer camp was attended by a modeler. And these are some of the statements that the modeler made in relation to that experience. What I think is most interesting is the reference to a kind of internal change, a kind of transformation of the person through this experience, right? Now, I feel more self-confident in talking to biologists. You might think, well, self-confidence is just kind of a nice artifact of a kind of learning experience, but it also makes possible certain kinds of interactions. If the person feels more self-confident, the interaction is more likely to take place. So it's I don't think something that can be isolated from the epistemic so cleanly. I know which experiments are more expensive to do and which are a lot more labor, and I realize there's a lot of human error. So this kind of expansion of knowledge as well as these other kind of dispositional gains. The second case, there was an introductory biosystems modeling course that was taken by an experimentalist and who had this to say about it: oh, I get it. I get what you're doing now, right? This kind of change in understanding. I'm now going, oh, that's what he wanted. That's what he needed. It's like my whole training was don't make assumptions, but now you have to make them. I'm a changed woman. Now most of my brain is going, what? Where are you getting rid of data points? And the other part's going, look, a smooth curve. So there's this kind of a dialogical, right, affordance that through this particular kind of experience. So what I want to leave you with is the idea that interdisciplinary virtues require not just personal dispositions, but environments that can cultivate and facilitate those dispositional changes, that learning and research environments must support and nurture these kinds of interdisciplinary virtues in order for them to develop. And I would also argue that these same virtues are important at the level of the research team, especially if it has interdisciplinary composition. Okay, thank you.
Do we have any questions? Yes, Ulrika.
Yes, thank you for a very interesting talk. I have experience of being both the experimentalist and the modelers, and I've been working in teams where there are both kinds. And sometimes I hear that the experiment say that, oh, I wish I knew more modeling, but I don't understand it, and I probably never will. And so there is some kind of idea that they wanted to know more, but they see it as a barrier that they will get it. So do you have a comment on that?
Well, again, I think this is why these kinds of experiences that give people the opportunity to understand from the point of view of the other discipline are extremely important. I think before that, in both of these cases, what you have just described would have been what we would find, right? And this is only after such a targeted experience, but it's a relatively small intervention, right, that can make a big difference, that can have big gains. Oh. And also, of course, conversations are important. I mean, it's kind of a reciprocal education that also helps, but this is just another piece of it as well.
Right.
To what extent are these traits acquired? Or to what extent are they actually there from the beginning?
Well, you know, both, of course. That's the nature of virtue. There has to be some basic ability level and some basic, I think, dispositional characteristics as well. Some people are more comfortable with uncertainty. Some people are more driven by an interest in complexity. These are perhaps just personality characteristics at some level. But then also, of course, experience does change us. So this is why they are a combination of natural ability and acquisition through practice.
But you haven't done any longitudinal studies following a group of people from preschool and then see
Certainly
who
not,
became
no.
scientists and what kind of... That would be fascinating.
That would be.
We have another question here.
Hi, I'm Åsa Knagård at Political Science here in Lund. Really appreciated the talk. I wanted to ask about these positionings that people do of others. Do you think that that is, in order to get beyond that situation where we have all these positioning of thinking ill actually of our colleagues, do you think it's important that you bring that up for us as researchers to actually be able to see that, to be conscious about that, to be able to overcome it?
Thank you. That's an excellent question. With positioning theory, the idea is we can't get beyond it, right? It's in all discourse, in all forms of talk. But the most we can do is become aware of it. And then your question is really more about the benefits of sharing it. And I think this brings us back to where's Michael? Michael's talk, right, about the importance of very targeted opportunities for communication. I mean, I think just, saying this in the break room over coffee would be potentially destructive, but if it could be a very well-structured conversation when assumptions and biases really toward the other group are shared in a constructive way, then it could have the potential for a great deal of constructive effort, I think. Thank you.
Thank you.